Question 8b is asking us about reduction and oxidation reactions, so redox reactions, and how they work when we're dealing with an anode and a cathode and an electrochemical cell. So the first part of it is saying, hey, you know that lead 2 bromide can conduct electricity when it's in its molten state, but it cannot when it is in its normal solid state. And why is that? So when it's in its solid state, the ions can't move. They're in their crystalline structure, they're not free to move around. When they are molten, so basically a liquid, they can move around. So the ions of the lead 2 and the bromine are able to move. And when we have ions that can move, we can conduct electricity. The second part of the question is asking us to tell what the half reaction is at the anode, the positive electrode where electrons are coming from, and identify whether it's a change is oxidation or reduction. And we have our bromine for our anode. I have 2 Br, 1 negative, forming Br2 plus 2 electrons. Notice my bromines are the same on each side. I have 2 and 2, and I have a total charge of a negative 2 on this side. Br2 would be a charge of 0, or an oxidation number of 0 overall, so we have to add 2 electrons to it. When this occurs, when I have electrons going this way, I have oxidation. Part 3 is looking at the cathode, and that is where I have my Pb, my lead 2 plus 2 electrons, forming solid lead. And this is where reduction occurs. The next question, 8c, is asking us about organic chemistry. First of all, it says, looking at this change, if I'm using K2Cr2O7 as an oxidizing agent, that's what ties it into the last 2 questions, what color change will I observe? And that's where we go orange to green. And then it says, let's name the compounds A, B, and C. One of the most straightforward ways of doing this is drawing them out first. And when you do draw them all out, you will see that A is propan 1-all. So on my first carbon, I have an OH group attached to it, making it an alcohol. B, once I've done that oxidation, becomes propanal. That al means I'm an aldehyde now. I have a double bond to an O. Then finally, you see in the end that we have 2 oxygens now rather than 1. If I was to draw it out, I would see that I have still a double bond O, but that carbon that had the double bond O now also has an OH group. So if I have COOH, that is an acid, and when we're dealing with 3 carbons, it's propanoic acid. Carboxylic acid with 3 carbons is propanoic acid. So A, B, C. Compound A reacts with ethanoic acid to form compound D with a molecular formula of C5H10O2, and state whether the reaction occurring, or what type of reaction this is and deduce the name for compound D. This is a condensation reaction. Or we could also call it an esterification because we are forming propyl. Ethanoate. And finally, it's asking us to look at intermolecular forces, so the forces that are in between different compounds, not actual bonds, and figure out why compound A has a higher boiling point than compound B. A higher boiling point means that it takes more energy to overcome those intermolecular forces. So it means that A is being held together more tightly than B. And that's because A has that OH group, which means I have hydrogen bonding. Which, remember, hydrogen bonding is a misnomer because it's not actual bonding. There is an oxygen-hydrogen bond here. That's what makes it such a big electronegativity difference. But this is not bonding with the other propan 1-alls. When we talk about hydrogen bonding, we're talking about an intermolecular force. So what's keeping all of those propan 1-alls so tightly together that it's going to take more energy to raise the temperature enough and the energy enough to get the higher of the boiling points. In B, we only have a C double bond O, which is not as strong as a hydrogen bonding. This is a dipole-dipole bond because there is an electronegativity difference, but it's not nearly as much as the hydrogen bonding. So we have a weaker attraction, which means that it's going to take less energy for the molecules to overcome those forces holding them together to start boiling off.